All right, everyone. We had a little bit of homework over the night last night. One of the questions we had was question number 6 on the worksheet. We're going to go over that right now. Looks like the one that you see up on the board there right now. There's another one that I gave you on the board yesterday that we'll do in just a couple minutes after we're finished going over number 6 on the worksheet. So we wanted to find the displacement here. We wanted to add these vectors together. I could ask this in any one of a number of ways. Add the following vectors. Find the total displacement. Okay, find the sum of all the vectors. It's all the same thing. Okay, all means the same thing. You got a vector diagram drawn here, except for a resultant vector, which is drawn from start to finish. We have to add these up now in components, ideally to get a right-angled vector diagram triangle. That's the goal here, right? Get a right-angled triangle. So we break it up into x's and y's. All right, can you tell me here, how many vectors do we have? 1, 2, 3, 4, 5 vectors. Can you tell me what the x value is of the first? You know what, actually? Before we do that, what should we do? Before we do x's and y's, let's do what? Yeah, let's get rid of the funny angles. Okay, let's get rid of those funny angles. So let's go off to the side over here. Okay, we got 2 funny angles. We've got 30 meters at 30 degrees. This is x, this is y. We're going to find the x side of it by using the cosine function. Cosine 30 degrees is equal to x over 30. What's it going to give me? 30 cosine 30, 25 point something. 25.98, thank you. And the y component is the opposite side of the triangle, so we're going to use sine for that. Sine 30 degrees is equal to y over 30. Y component ends up being equal to 15 meters. All right, got the first one. I can, if I want to, replace this now with this. 25.98 and 15. This is a little awkward because you're going up and then straight back down, but that's okay. Okay, not a big deal. Let's do the other one here now while we're at it. We've got 30 meters this time at an angle of 40 degrees. This is x, this is y. The x side is the adjacent side of the triangle again, so let's make it cosine 40 degrees is equal to x over the hypotenuse. 30 times cosine 40 is, someone's got to have that. I don't know what that is in my head. 22.98, thank you. And the y component is going to be used by the sine function, or found by the sine function. 30 sine 40 is 19.28, thank you. All right, now I can replace that other one with 22.98 to the left. Yeah, we don't need to redraw our vector diagram, but for some people it's helpful. For me it is. 22.98, and then the next one was 19.28. Okay, now let's go into what we were going to do first, do the x and y components of all of these vectors here. The x component of the first vector. Jacob, what do you get for the x component of the first vector there? Sorry? No. No. Kevin? 50. Let's make it negative 50 though, because it's to the left. What's the y component, Jacob, of the first one? No. First one. The y component of the first one. Right. The y component of the first one is 0. It's okay. We'll come back to it another time and you'll be right on it next time. Second one. What's the x component of the second one, Allie? Yep. Good. What's the y component of the second one, Tony? This is the second one right here. Good. What's the x component of the third one? Leah. Good. Positive 25.98. And the y component of the third one, Aiden? 15. Good. The x component of the fourth one, Bart. The x component of this one. Good. What's the y component of that fourth one, Zane? Good. And finally, the fifth one, the last one, the x component of the last one, Stephanie. Almost. Negative 22.98, good. And the y component of the last one, right? 19.28, good. Now we got to add these together, and sometimes the math is a little bit easier than it is for this one. Not a big deal, though. Just pull out the calculators for it. We got neg 50 plus 25.98, subtract 22.98. Can't even subtract on my calculator. What's wrong here? Oh, subtract. Negative 47. Now we do the same thing for the y components. Neg 25 plus 15, subtract 60 plus 19.28. Negative 50.72. So we draw it. And it's going to look like this, right? R is the square root of 47 squared plus 50.72 squared. What's that give me? 69 meters. Okay, and theta, we got opposite and adjacent. Theta is the inverse tan function of opposite over adjacent. 50.72 divided by 47. What does it give me for the angle? 42 degrees south of west. Anybody say 48? 43? Anybody say 47 degrees west of south? Okay, 47 degrees west of south, that would be good too. Both of those are correct answers. All right, good? You guys are superstars at this, right? It's too bad that I'm going to give you that little quiz redo on the V versus T graph, because what I was going to do on Monday was give you a quiz on this stuff on Monday, but we'll have to wait till Tuesday, I guess, now to give you the quiz on this stuff. Oh my goodness. That was the one that I put on the board yesterday. The only good news here is that our angles are relatively easy ones to deal with, 60 degrees and 30 degrees. Let's go off to the side here. Let's draw our 60-degree angle. 15 meters, this is x, this is y. Cosine 60 degrees is equal to adjacent over hypotenuse. That's going to be 7.5. Sine 60 degrees is equal to opposite over hypotenuse. That's going to be equal to, give me a second, 12.99. Okay, we got the first one taken care of. We can, if we want to, replace that. We don't have to, right? We can leave it drawn the way we did and just look over at the work we just did, or we can just physically replace it just so we don't have to worry about forgetting. Okay, now we got another funny angle. We'll deal with that over here. We've got 30 degrees right here. This is x, this is y, this is 10 meters. We're going to say cosine 30 degrees is equal to x over the hypotenuse, the adjacent over the hypotenuse, 8.66, and sine 30 degrees is equal to opposite over hypotenuse. So far, so good? Let's replace it. We don't have to again, but sometimes easier if we do. So let's draw this one over here, 8.66. Let's draw this one up, 5.0. All right. That's not so bad. Look at these 90-degree angles that we like. Remember what we say when we see the non-90-degree ones, the 30-degree ones, the 60-degree ones, the 40-degree ones. I don't like funny angles. Okay, so I got rid of them here. Now I got angles that I do like. Let's add up all the components here now. We can find some space to do that. Let's do it right here. It's not very much space, but I just want to be able to see the diagram as I'm doing it here. Hey, what's the x component of the first one at 20 meters? Zach, what's the x component of that 20 meters? 0. What's the y component of that 20 meters? Good. The x component of the second one, that green second one there. Jared? 7.5. What's the y component of that second one? Jordan? 12.99. Good. The x component of the third one, the 25-meter one. Carrie? The x component of the 25-meter vector. Good. And what's the y component? Good. Negative 25. Excellent. The x component of the fourth one, which is this green one that you see right there. Ryan, what's the x component of the fourth one there? Good. You know what? Actually, at first I was a little confused there, but it makes sense now. Makes sense now. Brian. Sounds almost the same, except the B part and the T in the end. Other than that, it sounds the same. Brian, what's the y component of that fourth one? Good. And what's the x component of the fifth one? Who haven't I called on today? Caitlin. The x component of this one. Jacob. What's the y component of this? Negative 20. Very good. Oh my goodness. What's the x component of the next one? Haley. Good. And the y component, Haley? 0. And finally, Seth, our superhero of the day. Just don't make him fall. Just don't let him fall. Good. Let's add these up. Okay, you guys, this half of the room, we're going to add up the first one, the x component. This half of the room, you're going to add up the y components, okay? Carrie, what do you get for this one? 28.4. You guys agree with that? No? Oh, good. 28.84. So you probably just missed a number, a digit on your calculator. You guys agree with that? All right. This side of the room, what'd you get for the y component? 90.3. Negative 39, huh? Negative 39.01. All right, so now we combine them. We're going to say 28.84 this way. We're going to say 39.01 this way. The resultant vector, angle is drawn at the start of the vector diagram. The resultant vector is right here. Let's say it's the square root of 28.84 squared plus 39.01 squared. Okay, you guys calculate that. Okay, you guys on this side calculate that. And over here, we're going to find theta. It's the inverse tan function of opposite over adjacent. Hey, which side is the opposite side? Is it 28 or is it 39? Alana, which is the opposite side, 28 or 39? To the angle right here. Is what? 39? Yes. Yeah, good. So it's 39.01 divided by 28.84. Remember, that angle's got to be drawn at the start of the diagram. Opposite side to that is the 39.01. Okay, this side of the room, what do we get for R? 48.51. We're actually going to round that to 49 meters. Okay. Significant figures, guys, remember, you always go back to your data. Okay, 20 meters, 25 meters. These are all 2 digits. That means the final answer will have 2 digits. Always go back to your least precise. If one of them had 1 digit, we'd round it to 1 digit. Okay, if they all had 3 digits and only one of them had 2 digits, then we'd round it to 2 digits. Always go back to your least precise piece of data, round your final answer to that number of digits. Theta, you guys on this side of the room, what'd you get? 54 degrees. And it would be 54 degrees what of what? South of east or east of south? It's south of east. Yeah, you're right. 54 degrees south of east. It's east, then south, or south after east, or south of east. Now, you could have just as easily expressed that as 36 degrees had you drawn it like this. Anybody draw it like that? You would have gotten 36 degrees if you had drawn it like that, but what would your answer have been? Not just 36 degrees, but rather 36 degrees east of south, which is exactly the same thing as 54 degrees south of east. Good? Got it? All right. Good news. Want the good news or the bad news first? Oh, there's no medium news. You want the bad news first? I'll give you the good news first. Because Haley asked for the good news first. Good news is we're done. Want the bad news? Oh, this is perfect because it's, what a way to end Friday. It's doubly good news because there is no bad news. So it's just like, it's like 2 bits of good news. You thought there was good news and bad news. I'm telling you, there is no bad news. So really it's twice the good news because there is no bad news, right? That's it for today, guys. Have a good weekend.